Article 725.3 of the National Electrical Code, NEC, provides an exception to the general rule requiring electrical boxes for splicing conductors. This exception specifically applies to Class 2 and Class 3 remote control and signaling circuits. It permits these circuits to be spliced without solder and without the box at accessible locations, provided certain conditions are met. The first condition is that Class 2 conductors must be spliced with approved twist-on wire connectors listed for the purpose. The second condition is that Class 3 conductors must be spliced with approved insulation displacement connectors listed for the purpose. Let's delve deeper into the requirements and considerations surrounding this exception. Firstly, it is crucial to understand what constitutes a Class 2 or Class 3 remote control and signaling circuit. The NEC defines these classes based on voltage and power limitations, aiming to minimize the risk of electrical shock and fire. Class 2 circuits are generally considered lower voltage and lower power than Class 3 circuits, offering a greater degree of safety. Secondly, the exception provided by Article 725.3 is contingent upon the splices being made at accessible locations. This means that the splices must be readily available for inspection, maintenance, and repair without requiring significant disassembly or damage to the building structure or finish. Accessibility is a key factor in ensuring the continued safety and reliability of the electrical system. Thirdly, the use of approved connectors is paramount. For Class 2 conductors, only twist-on wire connectors listed for the purpose are permitted. These connectors are designed and tested to provide a secure and reliable electrical connection while maintaining adequate insulation and mechanical strength. Similarly, for Class 3 conductors, only approved insulation displacement connectors listed for the purpose are allowed. These connectors offer a different method of making the electrical connection, but they must also meet stringent performance and safety standards. Fourthly, it's important to note that the exception provided by Article 725.3 does not apply to all types of low-voltage circuits. It is specifically limited to Class 2 and Class 3 remote control and signaling circuits. Other types of low-voltage circuits, such as those used for power-limited fire alarm systems or communications systems, may be subject to different requirements regarding splicing and the use of electrical boxes. Fifthly, even when the conditions of Article 725.3 are met, it is always a good practice to exercise caution and follow industry best practices when splicing conductors. This includes ensuring that the conductors are properly sized for the circuit, that the insulation is intact, and that the connectors are installed correctly. Additionally, it is advisable to protect the splices from physical damage and environmental factors such as moisture and corrosion. Sixthly, the NEC is a comprehensive document, and it is essential to consult the latest edition for the most up-to-date requirements. Furthermore, it is recommended to seek guidance from a qualified electrical inspector or engineer if there are any questions or uncertainties regarding the application of the code. Seventhly, consider the environment in which the wiring is installed. The question mentions plenum-rated wire. Plenums are spaces within a building used for air circulation, such as above suspended ceilings or under raised floors. Wires installed in plenums must be plenum-rated, meaning they meet specific fire resistance and low smoke-producing characteristics. Using plenum-rated wire does not automatically exempt you from box requirements unless Article 725.3 applies. Eighthly, while Article 725.3 allows splices without a box in certain situations, there may be other reasons to use a box. For example, a box can provide physical protection to the splice, especially in areas where the wiring may be subject to damage. Additionally, a box can make it easier to access the splice for future maintenance or modifications. Ninthly, it's crucial to distinguish between splices and terminations. A splice joins two or more conductors together, while a termination connects a conductor to a device such as a switch, receptacle, or lighting fixture. While Article 725.3 addresses splices, terminations are generally subject to different requirements. Tenthly, always refer to the product listings and instructions for the specific connectors being used. The listing information will provide details on the approved applications, voltage and current ratings, and installation procedures. Using connectors outside of their intended purpose can compromise the safety and reliability of the electrical system. 11thly, remember that the NEC is not a design guide. It sets forth minimum safety standards, but it does not provide detailed instructions on how to design an electrical system. It is the responsibility of the designer to ensure that the system meets all applicable requirements and that it is suitable for the intended use. 12thly, local jurisdictions may have additional requirements or amendments to the NEC. It is essential to check with the local electrical inspector to determine if there are any local regulations that apply to the project. 13thly, consider the long-term implications of splicing without a box. While it may save time and money in the short term, it could potentially make future maintenance and modifications more difficult. It's important to weigh the costs and benefits of each approach before making a decision. 14thly, document all splices and terminations in the electrical system. This documentation should include the location of the splices, the type of connectors used, and any other relevant information. This documentation can be invaluable for future troubleshooting and maintenance. 15thly, regular inspections of the electrical system are essential to ensure its continued safety and reliability. These inspections should include checking for loose connections, damaged insulation, and any other signs of deterioration. 16thly, if any problems are detected during an inspection, they should be corrected promptly by a qualified electrician. Ignoring electrical problems can lead to serious safety hazards, including electrical shock and fire. 17thly, understand the difference between listed and labeled products. A listed product has been tested by a recognized testing laboratory and found to meet certain safety standards. A labeled product bears a mark or label indicating that it has been listed. Only use listed and labeled products in electrical installations. 18thly, be aware of the different types of wire connectors available. Twist-on wire connectors are just one type of connector. Other types include crimp connectors, insulation displacement connectors, and terminal blocks. Each type of connector has its own advantages and disadvantages, and the best choice will depend on the specific application. 19thly, when using twist-on wire connectors, be sure to strip the wires to the correct length and twist them together tightly. A loose connection can cause overheating and potentially lead to a fire. 20thly, avoid over-tightening twist-on wire connectors. Over-tightening can damage the wires and reduce the effectiveness of the connection. 21stly, when working with electrical wiring, always de-energize the circuit before making any connections or splices. This will help to prevent electrical shock. 22ndly, use appropriate personal protective equipment (PPE) such as safety glasses and gloves when working with electrical wiring. This will help to protect you from injury. 23rdly, if you are not comfortable working with electrical wiring, it is best to hire a qualified electrician to do the work. Electrical work can be dangerous, and it is important to have the necessary skills and knowledge to do it safely. 24thly, remember that electrical codes and standards are constantly evolving. It is important to stay up to date on the latest requirements to ensure that your electrical work is safe and compliant. 25thly, consider attending electrical training courses or workshops to enhance your knowledge and skills. These courses can provide valuable information on electrical codes, safety practices, and installation techniques. 26thly, network with other electrical professionals to share knowledge and experiences. This can be a valuable way to learn about new technologies and best practices. 27thly, utilize online resources such as websites and forums to stay informed about electrical topics. However, be sure to verify the accuracy of the information before relying on it. 28thly, always follow the manufacturer's instructions when installing electrical equipment and components. This will help to ensure that the equipment is installed correctly and that it will operate safely and reliably. 29thly, keep a well-organized toolbox with the necessary tools for electrical work. This will make it easier to complete tasks efficiently and safely. 30thly, inspect your tools regularly to ensure that they are in good working condition. Damaged or worn tools can be hazardous to use. 31st, store your tools in a safe and secure location when not in use. This will help to prevent them from being damaged or stolen. 32nd, be mindful of the environment when working with electrical wiring. Avoid damaging trees, plants, or other natural resources. 33rd, dispose of electrical waste properly. Do not throw electrical components or wiring in the trash. Instead, recycle them or dispose of them at a designated collection site. 34th, be aware of the potential hazards of working in confined spaces. Confined spaces can present risks such as oxygen deficiency, toxic gases, and electrical shock. 35th, follow proper lockout/tagout procedures when working on electrical equipment. This will help to prevent accidental energization of the equipment. 36th, be aware of the potential for arc flash hazards when working on energized electrical equipment. Arc flash can cause serious burns and other injuries. 37th, use appropriate arc flash protection equipment such as arc-rated clothing and face shields when working on energized electrical equipment. 38th, follow safe work practices when working at heights. This includes using fall protection equipment and maintaining 3 points of contact. 39th, be aware of the potential for electrical hazards when working near water. Water can conduct electricity, so it is important to take precautions to avoid electrical shock. 40th, use ground fault circuit interrupters, GFCIs, in areas where there is a risk of electrical shock from water. GFCIs can quickly detect and interrupt electrical current, preventing serious injury. 41st, be aware of the potential for electrical hazards when working outdoors. This includes lightning, wind, and rain. 42nd, take precautions to protect yourself from the elements when working outdoors. This includes wearing appropriate clothing and using sunscreen and insect repellent. 43rd, be aware of the potential for electrical hazards when working near underground utilities. Before digging, call 811 to have underground utilities located and marked. 44th, be respectful of property owners and their property when working on electrical projects. Obtain permission before entering private property and clean up after yourself when the work is complete. 45th, be a responsible member of the electrical community. Share your knowledge and experience with others and promote safe electrical practices. 46th, the 15 volts direct current voltage is a low voltage and inherently safer than higher voltages such as 120 volts alternating current or 240 volts alternating current. However, safe work practices should still be used because any voltage can be hazardous. The 15 volts direct current would still require appropriate wire size based on the amperage of the circuit. The wire connectors still need to be properly listed for the application. The 15 volts direct current cable will need to have an appropriate insulation rating. 47th, consider the ampacity of the wire. Ampacity refers to the current carrying capacity of a conductor. The NEC provides tables that specify the allowable ampacity of different types of conductors based on their size, insulation type, and installation conditions. It is important to select a conductor with an ampacity that is sufficient for the circuit it will be serving. Overloading a conductor can cause it to overheat and potentially lead to a fire. 48th, when selecting wire connectors, be sure to choose connectors that are compatible with the type and size of conductors being used. Using incompatible connectors can result in a poor connection, which can cause overheating and potentially lead to a fire.